This conference will now be recorded.
These webinars aim to explore new and provocative topics in plant genetic resources. The webinars will take place on the third Thursday of every month from 3 to 4 p.m. Central European Time. And the topics have been selected to propose new, speculative, and perhaps even provocative ways of thinking about gene bank issues. The aim is that we shed new light on routine questions and create a space for thought-provoking discussion. So we very much look forward to having you and your colleagues join us in the months to come. It's my pleasure today to introduce our first speaker in this webinar series, Dr. Theo van Hintum, head of the Center for Genetic Resources, CGN in the Netherlands. We have posted in previous messages his curriculum vitae and some of his recent publications, so be sure and check up on what he's published recently. Theo has led research efforts that have been both aspirational and inspirational in many ways, and for many of us. So it's very fitting to have him as our first speaker in this GROW webinar series. Theo will be covering 3 topics today. The first is CGN's new viability monitoring protocols. The second is CGN's approach to seed lot management. And lastly, and perhaps most interestingly and exciting, is he will demonstrate a very useful tool for curators and users to visualize essential information about art collections. The title of Theo's talk today is Rethinking Gene Bank Management, Some Critical Thoughts and New Approaches. Welcome, Theo.
Hello. I can't see myself, but that's not necessary. What a pleasure to be invited, Yanni and Faith, to this first GROW webinar. It was quite a challenge, and I don't know whether I can live up to your expectations, but I'll do my best. We started half an hour late, so I'll try to go as quick as I can. Could somebody give me an indication on whether you can see my screen now?
Yes, Theo, we see the first slide. And we hear you very well as well. We hear you well.
Okay. We practiced with the Zoom platform, so switching the screens will be a little challenge later on, but we'll solve that too. So, good afternoon, evening, morning, wherever you are. It's a pleasure to talk to you about an issue close to my heart, and that's gene bank management. The rethinking part is seems to be a theme in my life, that I tend to have critical thoughts about all issues and propose the new approaches. But let's get strange things are happening. I hope you can still hear me, and otherwise give me an indication.
Yes, we can hear you too.
Yes. Hi, Theo. This is Andreas speaking.
Hi, Andreas. Welcome. So after the short introduction of CGN, I'll move to the topic of the rethinking gene bank management. List a number of topics that could be covered under that heading. Then go to our new viability monitoring system that we have implemented. Spend a little time on seed lot management, and then some time on that monitor that we've developed here as a prototype. I hope not to talk more than the minutes as indicated in this slide, to have sufficient time for you to give feedback. I do not know exactly on this platform how we're going to organize that, but we'll see how it comes. So let me start with the introduction of CGN. I can be relatively brief. We are the Dutch Genetic Resources Center for Plants, Animals and Forestry. But this workshop is strictly about the plant genetic resources group. I'm only head of this group, by the way. In the introduction, Yanni gave the impression that I'm leading the entire thing. That's not the case. To give you an impression of the size of the operation, the plant genetic resources unit has this budget about this year, a budget of about 2 million. We have 10.5 positions, 12 people working for us. Of this budget, about 2/3 is funded by the government, and the rest comes from EU and other people who pay us to do work in this mandate. We manage an ex situ genebank of moderate size, 23,000 accessions. We have a strong focus on vegetables, but if you look at the actual number of accessions, you'll see that it's still mainly small grains, but they're so easy and cheap to maintain. We do maintain an active collaboration with the users. That makes us special, I guess. We're a small country, we have lots of plant breeders, so the plant breeding industry is very active, research community is very active, and it's all very close. So it's easy to be in touch. And that keeps us with our feet on the ground. We're not working in an ivory tower, and that's a problem that I see in many other genebanks, that it's difficult to know why you're doing what you're doing, and that's what this presentation is about. Since 2004, and that's early, I think we were the first genebank to have a quality management system, a formal one, which means that we're audited twice a year, once external, once internal, and get certified if we live up to the expectations. Quality management, important aspect of our activities, and I'll touch on that later on too. We're also involved in other PGR related activities. We are in touch with on-farm actors and try to support them. We are in touch with the nature conservationists, trying to make them aware of the crop wild relatives that that they have on their fields and terrains, and try to create access to the material in those programs. We're involved in policy development in the ITPGRFA, the international treaty, but also in the ABS and DSI debate, access and benefit sharing, and digital sequence information debate. Since we're now on a dedicated platform, we don't have intruders, so all of you know what those letters stand for. I don't have to be too careful with abbreviations. We finally also try to collaborate as much as we can. Be active in ECPGR, be active in EU projects and crop trust and so forth. Of course, any organization is as good as its staff, and these are the people that do the work in the plant genetic resources group. I guess many of you know some of them at least. Now let's try to move to the movie. For that, I would have to stop sharing and start sharing again. How do I do that? Can somebody help me? Pompidom. Yesterday we practiced everything.
Yes.
But
Do you have your movie open? If the movie is already open, you can share that screen where the movie is still.
Okay. I should have that open. Yeah, I have it
now
open.
Share that screen, and we should be able to see it once you share it. There, perfect.
Okay.
Yes.
You hear some beautiful music?
No, I think the sound needs to be turned on.
How do I turn on the sound?
Down below, there should be a sound monitor for, just like you did yesterday, you turned on the sound.
Yeah, but that was Zoom, Yanni. This is another interface. As said, we practiced so nicely, but
right.
that.
Yes, I know. Sorry about that.
Okay. Otherwise, we skip the video.
Well, no, I think we can still, there's still some value to see, we can read, because anyway, it was in Dutch. We can still
There
read
is
about what
subtitle.
they're seeing. Perhaps you can provide some commentary of who this person is, and then we can.
This is Rob van Treuren, the curator for the leafy vegetables. And this is the working area of our genebank, and shows some wild, or perhaps not even wild, but some seed material. I'll guess it's lettuce. Rob is explaining that much of our material is multiplied by the seed companies. So part of it we multiply ourselves, mainly the more difficult things. This is collected material. That was wild lettuce. This is some land races of grains. So this is some pictures from a collecting trip in Uzbekistan. We try to collect every year. Last year it didn't work because of Corona. So there you've got the seeds. This is a beautiful picture of a drone of our lettuce testing field. So we put it there to observe it. Usually we also invite many breeders to have a look at it and give their feedback. So we learn from their knowledge, and they're interested to see what we have. But due to Corona, it was not possible for them to visit the field. So we decided to make this video. It looked so beautiful. It's a beautiful crop. So Rob is telling us that these are mainly commercial varieties, and in the back here's some wild stuff. We also grow our reference material for the characterization. This is all lettuce, imagine that. The other guy is Chris Kick, who is now talking. Again, you hear our collaboration with the breeding industry and the research community. And this is, of course, the bottom line. We have to secure our food. These are our modest storage facilities. Here's the -20. Here, for every accession, we have different bags: germination bags, regeneration bags, user bags. We only have to take out a bag to distribute it. Okay, I hope this gives you a little impression of what we try to do at CGN. But and now I'll go back to the presentation. Imagine I have to do this again later on, but we'll manage.
Sorry about that, Theo. Yeah, if you just now put the presentation on, and then we'll carry on from there.
Yeah.
It's looking well, though, I must say. We saw it very well.
Okay. We have nearly 100 people. Well. Okay, I'll mind my words then. Okay,
Actually,
let's
we do have
continue.
100 people right now. Well, one person left, but we had 100 people there.
Well, great, yeah. Okay, so what are we going to talk about? This was the introductory part. Now we'll introduce the thinking, the topic. As you all know, gene banks started around the 60s and grew, and more came and did the same things as the old ones did, and it was an organic process. And coming from working collections or research collections, those collections grew, but logistics became complicated because the size became bigger and the use became more complex. Different people wanted to use it. We had to monitor the viability, so take out seeds once in a while. So those old working collections, that logistics didn't work anymore. The composition was not optimal anymore. And on top of all those problems, the legal and phytosanitary issues arose and became more and more complicated and important. So we can conclude that gene bank management has become a complicated discipline. And having grown organically from those working and research collections, possibly we're not doing it the right way anymore. So that's what this presentation will be about. Please, let's try to rethink the things we're doing. And I don't pretend to have the answers. I just want to seed that little thought in your heads. Let's think about how we do the things that we're doing. And a trick of doing that is asking yourself the question, how would we set up a gene bank from scratch? Always keep in mind the objective is to conserve PGR and make it available. That's clear, one way or another. And also keep in mind, keep your feet on the ground. Funding is always a major limiting factor. We can't do everything. We can't have perfect regeneration without any loss of genetic integrity, and in the meanwhile have 10,000 accessions of that crop. That's not possible. So we have to be aware that the things that we want have costs, and we can spend our money only once. So what could we think about? And I just list a number of issues. This list is not complete. Composition of the collection. What diversity do we want to sample? If we know what other collections have, do we try to get that material, so duplicating it? Or would we want to complement other collections? Of course, that depends on whether those other collections are reliable, whether we can trust on them, conserving it properly for the future, and whether they make it available to users in the way that I would like to do it, right? Do we focus on the cultivated material, so easy to use, or on the crop wild relatives, potentially more important, more diverse, but also much more difficult to conserve? How do we compose the collections within these groups? Difficult questions, but things we need to think about. And often these things were givens because those collections grew organically. We never made the decisions. And of course, where do we get it? Do we buy it in the shop and having modern varieties, or do we go collecting? Well, believe me, and I told you, we try to do a collecting mission every year. That's not easy, and that's very, very expensive. By the way, we have it paid by the breeding industry, but it becomes publicly available, all of it in time. Anyway, then the composition of the accessions, and that's an interesting one.
Theo, to interrupt briefly, Theo, are you sharing your slides? Did you share your PowerPoint right now? We see you speaking, but we have not seen your PowerPoint yet.
Ah, well, that didn't affect the number of viewers because that grew. Okay, what do you see?
You're right. Also, organizers, if possible, when Theo is talking, you can also spotlight him so we see his face, and that would be nice. There, thank you. We see it now. Thank you very much.
Okay. But you can hear me.
We heard you perfectly, yes.
Okay. And could you see me?
We could, yes, we could see
Okay.
you. Yeah, but organizer, you can also spotlight the person if they're talking. You can make them big on your screen. Thank you.
Okay, let me continue. So you didn't see the slides. Anyway, I hope that you could follow the presentation anyway. This is what you missed. So composition of the accessions. So the first decision on composition of the collection, what accessions to include, but then how to maintain that stuff. If we're talking about self-pollinators, there is an option of using single lines. Much easier to regenerate. Phenotypes and genotypes are directly correlated to the stuff, but of course you lose diversity within the accession, and you have to have many more accessions. But possibly cost-wise, I do not know how that would pan out. Or in the case of cross-pollinating crops, and recently in a DivSeq seminar, I heard about rye, where the diversity within the accessions is bigger than between the accessions. Why not bulk the stuff and have a few distinct bulked accessions, which then can be very carefully maintained? I don't know. I'm not saying that's the right thing. By the way, it's quite some time ago, but together with Rory and Jan and Bonwo and Melinda, we wrote a technical bulletin on this issue, on splitting and lumping. One of the least cited publications I wrote in my life, by the way. We also wrote a publication on the brassica situation. That's a cross-pollinator, and there we had those umbrella varieties, old Dutch land races, and different farmers had multiplied their own selections and sold them. And we had the selections of all those farmers. So Langendijk and Vroeger Boer selection Boersma was then the name of one of those. All those Langendijk and Boer, which was the name of a land race, were very similar. So we proposed to bulk them after looking at it at the field, having advice from scientists and breeders, and doing in that time isoenzymic analysis. Not one per land race, but we had a flat one and a tall one. But we managed to reduce the number of accessions in our brassica collection considerably. By the way, when we published, Genetic Resources in Crop Evolution didn't want to publish. They didn't like the fact that people bulked accessions. In the end, they did publish it with the footnote: we will encourage the publication of further results of research programs in our journal referring to such often controversially discussed concepts. I would appreciate blah, blah, blah. Anyway, that was a big compliment that they thought this was controversial. It was published anyway. That is long ago, 25 years ago. Other issues, conservation methods. Do we use clones or seeds or pollen or DNA? And especially with apple or potato, I couldn't answer why we're conserving the clones, for example. I do know the arguments, but are they that strong? Do they justify the costs that it involved? We could just as well take seeds here. The technical setup, what temperature do we use? Is it tradition that we use -20? Could we do it at -10 or -25? Small freezers, freezing rooms, what's the optimum? We have both at CGN, by the way. That's another story, I can tell it another time. Things to think about, they're not obvious. Regeneration methods, and that's that economical consideration. We don't want to lose diversity, so genetic integrity is important. For genetic integrity, you need high numbers of accessions, of plants per accession, large populations. But that means that the cost of those regenerations grow linearly, right? Which means that the number of accessions that you can do will decrease linearly. That's simple economics. So the investment needed to maintain genetic integrity during regeneration simply cannot be spent on increasing the collection size. That is a trade-off. Same story if it comes to viability monitoring. If you want to really be secure and we monitor it very frequently with very large number of plants, you're very sure that you will notice any decrease of germination. But of course, the cost will be very high. Possibly it's better to have the double number of accessions and lose one once in a while. I'm not saying this is the case. Think about it. We have to think about it. Other things, availability. How important is it to make the stuff actually available? Should we promote the use? Should we approach user groups and advertise the stuff, or possibly even do some pre-breeding? What conditions for access are we applying? And in Europe, luckily, most of us tend to use the SMTA, but possibly we cannot address some users under those conditions. And what service levels? And service levels is a complex thing. It has to do with access to information. What do we invest in that interface? At CGM, we created course selectors that on the spot you can create a cross-section of your selection if it's too big. What bioinformatics interfaces do we want to build and make available? But also in the field of consultancies, if a user comes to us and says, I'm looking for a line to cross to find disease resistance, how far do we go in advising? What research will we do for that user? Difficult, because this is all very expensive, but also very important. The user gets happy, you get happy, believe me. Phytosanitary import permits, sending material, especially to Asia, it's a nightmare. All the statements that you need to give, the phytosanitary tests that are required, non-GMO statements. Can I guarantee that there are no GMOs in there? I can't. I can't just say best to my knowledge. How far do we go? Tell me. There's no consensus. Quality management. Do we invest in quality management? Yes. It's up to you. I think it's money well spent. But if we do, what system and to what level of detail? Some have protocols and a very light way of monitoring. Others have a firm certification, like ourselves, as I showed, the ISO certification. Some other issues, and I won't discuss them all, but I just wanted to list some more. Automation. Do we use image recognition? There are plenty of possibilities. Also in a recent DivSeq presentation, some very nice ideas were presented, possibilities. The storage of material. I don't know whether you ever seen the Japanese genebank with robots picking up the cans from the storage. Very expensive. It's a possibility. Monitoring the regeneration, high throughput techniques, possibly with whatever. Throw the seeds in a machine and it tells you whether it has the same DNA signature as the original accession. Bioinformatics, it's coming. How do we use that bioinformatics data that is sweeping all over us? Optimize the collection composition. How do we support the users in selecting the material? Plenty of opportunities. The decision is up to us to decide how to invest in that, whether to invest in that, how much to invest in that, because our funds are limited. But also other possibilities. And I hope that Nigel Maxted is watching, because he would like to say this, integrating other actors. Could we act as a genebank, as an interface to resources maintained somewhere else? There are all kinds of possibilities. Let's think about it. Let's innovate. Let's change genebanks, make them better. So to close this part of the presentation, genebank management decisions are not written in stone. They are arbitrary. Funding is the limiting factor. The pros and cons of the decisions should be clear. Sometimes more research is needed. Where did we hear that before? A consensus in the community is difficult, because the optimal decision depends on the purpose of a genebank. And if you're closer to being a working collection for your institute, then access to external users is less important. If you're serving as an international genebank, conserving the material for perpetuity for mankind, then access is very important and the quality of conservation is very important. Difficult. Luckily, we do have genebank standards to support the collaboration, and that's that FAO publication. I have a picture later on. Important, good starting point. whatever decision you're taking as a genebank manager, make sure that they're implemented correctly. I visited many genebanks and I've seen that the story of the manager often differs quite a lot from the daily practice. Life sucks, that's reality. How to avoid that quality management. And quality management is not to check on your employees, but it is a way to assure that the quality is appropriate and that you are following the protocols that you've decided together with your staff, I hope, and follow international consensus if that exists. I think this concludes this part of the presentation. Yanni, what do you think? Should we open the floor for discussion now or do it at the end? Also looking at the clock.
Yes, I've asked people, if you have a question, please post it in the chat. Faye and I will be monitoring and we'll post it when there's a lull in the conversation. Otherwise, you can unmute yourself and ask the question directly if you have any queries for Theo. I would suggest that we continue with the viability monitoring, and if anybody has any questions, just please proceed either through the chat or directly unmuting yourself and asking the question. Thank you.
Let's do the chatting is always possible. Let's do the questioning after the viability monitoring, because there I assume that you might have questions. For that first part of the presentation, it was just me babbling about the perfect genebank. Let's continue with the content. Okay, we all know if you are managing a seed genebank, you have to monitor the quality of the seeds. If they die, the accession is gone. You could choose to simply regenerate once in a while and hope that the stuff stays alive. Could work, but all genebanks somehow monitor the viability. All, anyway, most. Some standards have been defined, and that's that cover of the genebank standards. If you don't know it, make sure you know it. This is ABC for the genebank community. They say the initial value should be above 85%. The threshold for regeneration should be 85%, adding or lower depending on the species or specific accessions of initial viability. Well, and the number of seeds, they don't say much. It depends upon the size of the accession, but should be maximized to achieve statistical certainty. However, the sample size should be minimum to avoid wasting seeds. Duh. I mean, that could mean anything. And you know sampling effects. If you would only take 50 seeds, right, and the true germination is 80%, then you can be sure that 19% of the tests will result in values over 85%, simply because of sampling effects. This means that nearly 1 in 5 decisions you make regarding not generating is not right, because the actual germination is below the threshold. So when defining threshold, one also needs to define probabilities of exceeding that threshold. I won't go too deep into that right now, but we did think about that at CGN. So how did we monitor the viability previously? We tested our germination by ISTA labs. We simply send away 200 seeds and got the germination back. They used the ISTA protocols. Apart from that 200 instead of 400 seeds, ISTA requires 400 seeds, and we use 200. But what we did, we sent every year 5 to 10% of the accessions again as blind doubles, so we could check the reliability. And the only conclusion was that that was very low. And as a result of that, we made very many wrong decisions. We decided to regenerate, and a shortened, which means that we made the generation span unnecessarily short, which is not desirable, and generated unnecessary cost. Or we decided not to regenerate with the risk of losing the accession. By the way, we never lost an accession, but that's a sideline. As an illustration, here you can see the picture from from the paper on plant genetic resource conservation and use, where the first germination test result is plotted against the second. This should be a straight line if it was perfect. It should be a cigar if it was real, but this is more than a cigar. This is a balloon, and this is not acceptable. You can see all this stuff would result in wrong decisions. Anyway, so we started thinking about doing it otherwise. Why did it go wrong? Oh, by the way, we made a little inventory of how other genebanks are doing it, their germination testing, and then also the period between the tests. Everybody does it differently. We made a small inventory which is available on request from us. Why is it so difficult? It's so difficult because those ISTA labs and the standard ISTA procedures assume very good seeds. They expect this type of seedlings, right? And I mean, if they see the other type of seedlings, it's clear that this is not good. But there are stages in between, the gray area, and those analysts doing the tests at the ISTA labs are not that trained in deciding this is a good seedling and this is not. So as a result, in that gray area, and that's where we are, right? It is difficult, and they tended to generate quite a lot of differences there. As a result, have those significant differences also in those critical areas where we make our decisions. We were not happy, and it cost a lot of money. So we thought about an alternative. We set up in a few years a new protocol. We still apply, and that's the starting point, the same viability thresholds. We want to comply to the FAO genebank standards, but that 85% we interpreted as being 95% sure that germinability is above 80%. That's another way of saying the threshold. If you use 200 seeds, that's a way of saying the same thing as the threshold of 85. So we analyzed all germination test results over the last, well, since we existed, and decided that the first 25 years seed stays alive if you dry it properly, if you store it at -20, and if the initial germination is good. So every accession is tested before it enters the seed storage, and then we sit back and wait for 25 years. When germination viability needs to be tested, we use the following scale now, and this is interesting. 1, if it shoots out of the ground and all beautiful plants, we say it's very good. No worry, you can wait another 10 years until we do the next germination. Or 20 for the small grains, where apparently they don't die ever if you store them well, I think. I'm sure some of you are now very angry, but I don't care. Whoops. 2, still good enough, still above the threshold. But we do see the signs of aging plants. We see some chlorosis. It took a little longer for them to germinate. It's good enough, so we assume it's still above the threshold, but we should pay closer attention and test within a few years, test within 5 years, but the curator can decide for himself when he or she thinks the new test is necessary. 3, it goes below the threshold or on the threshold or there somewhere, and we should regenerate. No big hurry, but do that within a few years, say within 5 years. And 4 means this is bad. The stuff is about to die, regenerate as soon as possible. This is what we need to know. This is the answer. This is the information we need. And on this basis, one of those 4 scores, we can work. I'm not interested in a percentage of 84 if I do not know the reliability, if I haven't seen those plants. This is much more informative. We're not finished, and we might develop this protocol a bit further because we only have been using this 2 years. And we're still doing blind doubles also in this protocol to determine the repeatability. And another thing we would like to know, if we see bad seedlings, would it still grow into a healthy plant? So in that gray area, deciding between 2 and 3, it's good to grow some more plants to see where that line should be drawn. We're not ready yet, but we have introduced this system and it seems to be working. Now I expect some replies.
We do indeed have some questions in the chat, and I would like to post them. The first one is, how often do you regenerate your seed in your gene bank? And I believe you gave that answer, which is 25 years, 20 for some small grains. But go ahead, Theo, for that question.
No, we regenerate when the germinability of the base seed lot, and we'll get to that in a moment, starts to drop. And in many cases, and when we get to the monitor, we can have a look at that. In many cases, we never regenerated after receiving the seeds, and that is sometimes 40 years ago. So we only regenerate the base seed lot if the germination drops. That's the answer. And mostly that's after 30, 40 years.
Okay. 2 more questions from Andreas Grauner. The first is, interesting suggestion to bulk the seeds, but what about conservation of the cultural heritage? For example, fruit trees, heirloom, or amateur potatoes, that sort of question. What do you do with that, where there's very specific types of varieties of potatoes which need to be kept because they're heirloom?
Clear. Yeah, and I know that for SIP, that's also a thing, that they need to conserve the clones because they were donated and stuff. No, that's a strong argument. But I could imagine that if you have an apple collection of a few hundred, only 50 would qualify to preserve as a cultural heritage, and the rest could be stored as seed. I do not know. That was the first part of my presentation, and that was to trigger thoughts, to provoke. It's not what we do. We simply have a clonal apple collection, right? We do think about how to conserve that thing as optimal as possible and how to compose it. And that's what I'm calling for. But you're right. That could be a very strong and convincing argument to maintain the original accession. By the way, if we talk about Langendijk Vroege selection Bruinsma, right, and Langendijk Vroege selection Jansma, who cares if those two are merged to recreate the old landrace Langendijk Vroege? These are those old white cabbages from the Netherlands. So in some cases, yes, in some cases, no. Let's look for the optimal and possibly have different strategies for the same collection even. I don't know.
Yeah, along the same lines of that thinking and that answer is, how would you go about phenotyping bulk samples?
Well, how do you go about phenotyping the original samples? If I look at those, at the data presented by IPK on the right, I mean, the diversity with the single accessions is huge, and merging very similar accessions would not increase that diversity that much. But you have double the time to do your genotyping and your phenotyping because you only have half the number of samples to take care of. I'm not saying you have to bulk your cross-pollinators, please don't get me wrong, but think about the possibility. Don't act tomorrow. We're in the business of genetic resources conservation. We have to be conservative. But again, we have a budget. We can spend that budget only once. We have to make sure we spend it optimally. And that might involve bulking or harvesting seeds and freezing them instead of maintaining the clones. I don't have the answers to your questions. I can just propose questions to you.
Okay. A question from, there's 2 more questions.
Please.
This one is from Nigel Maxted. When selecting targets for active collection, how do you decide between the priorities to meet local breeder requirements compared to maximizing the overall diversity that you conserve?
Very good. All questions so far have been very good. As indicated, collecting is a very big, expensive business. We have them largely funded by our user community. So in discussion with that user community, which are breeding companies, we see where in our collection there are areas that could deserve strengthening. We try to get it somewhere else in the world via requests. If we can't, if we have access to a country where there's diversity that matches the needs of the breeders, we go collecting. So it is a dialogue. I only can recall one collecting trip completely funded by the companies where we thought, well, more Lactocastorella from this country. It was another area. So I don't think we will include all that material in our collection because it seems a bit much. But the breeders are very interested in this stuff, right? And we collected it to make it in the end publicly available and preserve it for perpetuity. So we are very critical there. It is a balance, like everything in life is a balance between the needs of the users and between the needs of the future users for whom we conserve it in our collections.
Okay. We have another question from Nora Castañeda Alvarez. Aside from the number that you have for viability, you're now suggesting that it would be a very good idea to have the qualitative evaluation, the scale from 1 to 4. And the question is regarding that. Do you determine the proportion of seeds falling under the 4 qualitative scale categories? So is that something that you calculate? Is that proportion of seeds, or do you categorize the whole accession from 1 to 4 as to whether it's good, not so good, etc.?
Yeah. Again, a good question, a technical question. I made it very clear to our curators, who are very skillful and experienced, that they're responsible for keeping the stuff alive. And I know that some curators still record percentages. They all know if they do it in soil, and sometimes they sow 50 in soil, and if 50 plants shoot out of the ground, that's a 1. If they have to wait for 3-4 weeks before 45 plants have come up, right? In principle, it would be enough, but often they will do it on petri dishes with 100 seeds again. Yeah, the scoring is on an accession basis. And of course, if a curator doesn't feel secure with one of those 4 scores, he or she can record more and count or make notes or whatever, right? But in the end, we have to make the decision when to do the next regeneration, when to do the next viability check, and that is recorded in one of those 4 scores on an accession level.
Yeah, okay, thank you, very clear. A question from Juan Dominguez. What about sequential sampling? Do you recommend it?
Well, I already answered that in the answer to Nora, I guess. If you decide, and I'm not a crop curator, I do not know the optimal for the different crops, but I could imagine that you decide to do a test in the greenhouse of 50 seeds to see whether they shoot out of the ground, and very often that is the case. Our seeds are pretty good. But for the ones that don't shoot out of the ground, do later your petri dish determination or whatever method that you use. That could be considered sequential, although we don't use the percentages of the first test, but we do use the observation of the first test to determine the next step. So a kind of sequential. Sequential is very formal, doing your 50, and if you're in a shady area, you go to the next 50 and then have a more precise estimate of your germinability. But to me, that's not so very interesting. It implies to me that you're in that phase, in that zone where you should pay closer attention anyway, or possibly already schedule regeneration, because it's not perfect seed and it's not dead seed, right? So that's the logic.
Okay, we have 3 more questions, and I think we will continue with the seed lot management after you answer the 3 more questions, if that is okay with you, Theo.
Well, it's okay with me, but we might start losing attendance because it might take a bit too long, also giving the delay at the beginning. But let's do it, yeah.
Okay. Okay. A question from Manuela Nagel. Hi, Theo. For germination testing, are you suggesting to follow ISTA guidelines and apply your evaluation scale? Have you thought about dormant seeds?
Oh, certainly. Yeah, very good point. So the ISTA and the books are in our office, and I mean, of course, there's so much knowledge generated by ISTA, but ISTA does it for the commercial seed trade. They want to know whether they only want to have perfect seed lots, right? They're not acquainted to seed lots that are around 80% germinability. So it is relevant and important, but their methodology, we found out, is not that good for our seeds, given that unreliable results that we got back from ISTA certified seed labs. For example, and I'm not an expert here, but I think that they stopped their experiment after 2 or 3 weeks. Often our stuff germinates much slower. They're not familiar with wild material at all. Possibly you have to scar or use some gibberellic acid or whatever to do to get that growing. I doubt whether ISTA has rules for that, but I'm not the expert here, so I should be a little bit careful. There was another component to that question,
Have
Yanni,
you thought
please.
about dormant seeds, which I think you thought.
Right, dormancies. So the people doing the germination tests are very scrupulous and very careful. And if seeds don't germinate, they take them out and look at whether they're soft and moldy or whether they're still hard and probably dormant. All kinds of things tricks are done to break dormancy. So yes, dormancy is obviously very important, especially after newly regenerated material and the wild material. I don't have to tell you, you guys listening know more about these things than I do, but it is a very important parameter. We don't want to regenerate seeds because we oversaw that the stuff is dormant. Difficult issue, but a relevant issue. Thank you for that question. Yes.
Yeah. We have a good one here about oily versus non-oily seeds. I would like to know whether the viability monitoring plan for oily seeds as your gene bank is the same as for non-oily seeds.
Here, I do not see the relevance of seeds being oily or not, but that probably shows my ignorance. As far as I know, we treat them the same way. I do know that the oil content has a influence on humidity thresholds, but that's another story. No, I think that the same protocols, of course, the protocols for germination testing are crop specific and will differ from between crops, so also between oily and non-oily. But I don't think there's a systematic difference between the two categories.
Okay. And then
my curators might correct me here, by the way. Some of them are online.
Yeah, I think it's an impact on the longevity, and perhaps DNA Koti, if you would like to unmute yourself and provide a comment, that would be great. Okay, if not, then the last question for this section, is this new protocol that you're proposing with the qualitative scale an indirect way of estimating the accession's vigor instead of the viability? Will estimating vigor instead of viability lead to a more reliable estimation of seed longevity?
That's an interesting remark. Who made that remark, by the way?
Aravind?
Okay, thank you for that. No, with aging of the seeds, vigor will go down, will be an indication of the drop of the quality of the seed. So possibly we could call it a vigor test. You're right. I do not know exactly what the definition of vigor is, but if the seeds do germinate, all 50 or 100 or 200 that are sown, But if it takes them 6 weeks to generate and they still look very miserable after generation, we can say that the vigor is low, and this would be typically a 4 or a 3. I mean, this is not what we want in the genebank, and in a few years it might be that they don't germinate at all anymore. So yes, we might think about introducing that concept in describing this protocol. Yes, thank you for that comment.
Okay, I think for now, we'll wait until the next round of questions, but my suggestion, Theo, would be that you proceed with the seed lot management part. I think it's rather brief, and then we can take some more questions after that.
I still have 2 brief ones.
Okay.
So it's seed lot management, and here, and I'll start my talking again. I'm such a happy man. I like to talk, and my colleagues know that. But anyway, as said, I've been visiting and reviewing genebanks, auditing genebanks over the last years, and was very often surprised by the various seed lots that genebanks maintain. Why? Does it have to be so complex? And I have 2 slides now to tell you how we do it and why it is really not very desirable. Why do we have the seed lots? They serve basically 2 conflicting purposes. One, we have to make the generation span as long as possible, because every regeneration and rejuvenation threatens the genetic integrity. There will be human errors and genetic drift because the population size is never infinite. There will be natural selection. There will be elephants destroying, no, I do not know, not in the Netherlands. There will be all kinds of things that change the composition. There will be swapping that changes the composition 100%. Things go wrong. But on the other hand, we always want to have seed available for distribution. And seed stocks run out. So they need regeneration, in this case multiplication, creating more seeds, and rejuvenation, creating young seeds. These 2 are conflicting. Well, how did we solve that at CGN? And here, I think this is the way to go. We have a base lots and we have user lots. Every accession has a base seed lot. And that base seed lot can consist of user bags, regeneration bags, germination bags, and rest samples. Okay, these are separate bags. We can take one out and send it to the user, take one out, sow it, etc. We don't have to open containers. The viability of that base seed lot is monitored using those germination bags. We only regenerate when the viability drops below the threshold, or makes a too big step down, or if this base seeds run out. If we can't test the viability anymore, we have to regenerate. Then, for some frequently used accessions, we also have user seed lots. It consists of only user samples where we test the initial viability. We don't do any viability monitoring because they will have been regenerated after the base seed lot where we do test the viability. And we're not use it for creating new base seed lots, because the base seed lots are only created from seeds from the base seed lot. Graphically, it looks like this. Here's the base sample. Here's time. This is how time looks like. On the x-axis, the base sample we maintain as long as possible, and we only regenerate if the germination decreases or too little seed is there to determine the regeneration, the germination. As long as possible. But it can be that in the one regeneration we did for the base sample, we run out of user bags. And then we organize a multiplication of a user sample, which is then another seed lot. And if we run out of that, we regenerate it again. Or if we can take some base material for that, do it from base material. This okay, here, this user sample will be 2 generations away from the base sample, 2 regenerations away. That's true. Only 2, only 2. The base sample stays stable, and our grandchildren will get material that is also just 1 or 2 generations away from the original sample. I hope this is clear. If there are some urgent questions about this, Yanni, tell me.
Yes, I am looking. We still have a couple more that came in from the previous show, previous
Okay.
slides. But I can do those right now, or we can wait till the end to bring these back in for you to do your monitoring tool
Yeah.
demonstration.
Give me a few minutes to do the monitoring demonstration, because I don't want to miss that one. And we still have 133 people watching. Wow. If they would all, no. Anyway, this is a demo. I'll show you a live demo of the genebank monitor. Talking to genebank managers or curators. I'm, well, disappointed is not the word, because I understand. But if I talk to them and ask them, how is your collection composed? Look, if I'm lucky, they are able to say, well, 10% wild, 90% cultivated, and of the cultivated, it's mainly land races. If I ask a bit more, it stops. If I ask what is used, well, it's used considerably, but we send away every year 1,000 samples. But what material? Then it becomes a bit more. I think curators should have a much more better overview of their collections to make the management decisions that they need to make. And these are overview related to the composition of the collection, the use of the collection, the traits in the collection, the age of the seeds, and please continue for me. There are many more things that a curator should know to be able to make wise decisions. The data needed for that are in the database, but are often far from accessible. Okay, standard reports can be generated, but they will not be sufficient. You would want to know more than what is listed in that standard report. And you might have more complex questions that even if you're familiar with the interfacing language of the database are still difficult to answer. So it's difficult to get that information. So we started thinking about how this could be improved. And then I was in another context working with Microsoft Business Intelligence, which is an interactive interface to in this case management data of a foundation, and it's possible to zoom in to look at details. It was fantastic. I thought that should be possible for a genebank too. So we built genebank monitor. You'll see it in a moment. It's based on the diversity tree, and I could say more about that, but in the CG you're aware of this thing. Basically what it does, it says my collection is composed of vegetables and cereals. The vegetables, we have the leafy vegetables and the fruit vegetables. The leafy vegetables are composed of spinach, field corn salad, and lettuce. The lettuce is composed of wild and cultivated. The cultivated, you get my point. You divide it up everywhere. There's a branch, and there are no, there's a stem, and there are branches, and you repeat that in a fractal way until it makes no sense to divide it further. That's the diversity tree. And we need some statistics. Every accession has a position on the diversity tree, and every accession has statistics. It has been used so many times over the last years. It has been so long in the collection. The germination is this, etc., etc. That is what we need. That's all we need. Since then, we can make a genebank monitor. And now I'm challenged again to connect to the genebank monitor, and I hope it is still on despite all the issues we had. It got disconnected. I'll try to share the screen anyway, then you can see how it connects. Do you see a screen now?
Yes, we see a screen, Theo. And it's
Okay.
moving, so you're good to go.
Okay. I'm excited about this. Art van Bemmelen, and it's a shame he doesn't work for us anymore, created this. It is a prototype. It was built, oh, I have a slide on that later, but I don't know whether we'll go back to the slides. We'll try, but anyway, it's built in an R library, Shiny. Let me tell you what we see. We see here a variable, and I don't know whether it's big enough for you to see, but it says use per year. I could choose others, and it's just a prototype, so we just have 4 descriptors here. We could have more. As a plot depth, I choose 3, then it's still visible. Here is the CGN collection. And you can see we have cereals, leafy vegetables, fruit vegetables, legumes, etc. This is proportionate to the number of accessions in that component. In the leafy vegetables, we have lettuce, cruciferous, spinach, and there will be corn salad there. Let's have a look. Now leafy vegetables becomes the center, and we see it's cruciferous, lettuce, spinach, and lamb's lettuce. Yeah, that's the same as corn lettuce. If we click on a segment, it becomes the center. If we click on the center, it zooms out. Isn't this great? In the meanwhile, we get statistics about what is in the center in the histogram to the side, where we can also choose different variables. Okay, let's have a look at this. What do we see? The variable now is used per year. Interesting. Okay, we see that the cereals are hardly used in our genebank. Spinach, and in general, the leafy vegetables are popular. Let's have a look at spinach. Oh, leafy vegetables, how does it relate? Spinach by far, but if we look at spinach, we can see that it's mainly the cultivated material in terms of use per year, right? So that's the years that it has been in the collection, the times of use. And we can see that overall spinach, it's once per year. We only have 485 accessions. How long did we have these things? And then I look at the age. So the spinach collection is on the average 30 years old, but I could also plot the age here. And then we can see that the average age is 23.44 years. But we have some new material. What is that new material? And I'm so excited about this tool. It's really great. In principle, I can select that new stuff and get a list of that material down here. It's all Turkestana from Tajikistan, so recently collected stuff, right? Or let's look at something else. But I hope you get the gist of the possibilities here. If I look at the age of the base sample, and you know what the base sample is, right? That's the one that we maintain on the long run. And this is the entire collection. Then we see that we have material of 33 years old. So 40 was a bit of an exaggeration. On average, our collection, the base sample, is 21 years old. I would be very interested in hearing that from you guys, the other genebanks present at this presentation, how old on the average your seed is. I'm pretty sure you can't tell me. And even if you go out, I'm pretty sure that next week you can't tell me. This is something you should know. But we can also see that the maize collection appears to be pretty old, and all of it seems to be similarly old. And oops, all this stuff probably never has been regenerated while we're, no, the genebank is about 26, 27 years old. So there 6 have been regenerated. The rest was probably regenerated before we started CGN. Imagine that. But germinability is still good since we monitor that. But I do not know how that behaves in time. I would be a bit afraid when this stuff comes up and gets older and starts to deteriorate, because regenerating maize is quite a hassle, as you know. So imagine that we could go to lettuce and choose as a variate here Bremia resistance, and we could see where in the diversity tree the Bremia resistance is located. It's not loaded as a variable, And here you see that the diversity tree ends here with origin country unknown. There's no further division there. But for butterhead, that's Europe, Western Europe, let's have a look at that. The Netherlands, we have 314 cultivated lettuce from the Netherlands. That's quite a lot, and not really surprising, but anyway, you can see that's not further divided. I hope you have an idea of what this thing can do. We've seen, for example, IPK is doing a great work on creating visual interfaces, possibilities to do PCAs on the basis of molecular data, selecting with a kind of lasso material from that cloud of points. If we would be able to integrate these type of interfaces and be able to nearly touch the collection from behind the computer and get all the data that we need in an intuitive way, wouldn't that be great? We would be such good curators then, such good genebank managers. I'll go back to my presentation now. It's a bit difficult to swap between these things, but I'm getting used to it now. You see my presentation again?
Yes, Theo.
Okay. So I'm about to finish, and then we'll talk. This is the prototype, and I mean, if you want, you can have the code, but I think we should very carefully select the software that's most optimal. And possibly this R package is not the best. We didn't select the most optimal. We select this package because we were able to work with it. I do think that the genebank community would benefit if we would have a real nice type of interface as demonstrated just now. If we would have a whole suite of interfaces that would help us being better curators, better genebank managers. If you want to have a look at this prototype, here is the URL, and anyone can go there and play with it. Again, the data is very limited because we only loaded four variables because that served the purpose of demonstrating. I hope that you get the point. Here is the bottom line. We really need concepts, knowledge, platforms, tools to professionalize genebank management because we're still improvising. We should go to the next generation. And I thank you for your attention. It's getting late and we started late, but so I very, very much appreciate you all staying on for this long. If you want to leave, please leave. If you want to discuss, please stay and we'll have a little discussion now. Yanni, floor to you.
Thank you very much, Theo, for that inspiring presentation. Very nice points, and I think you opened our eyes regarding several of the topics and showed ways in which we can rethink what we're doing. We have, I think, a couple of questions. One was about sharing the code, and that you did there. So I'm going to skip over that one. It's an impressive tool. Is there any plan to develop it further and scale it out?
Thank you. First, concerning the availability of the code, if you send me an email message, I will send you the code and do whatever you like with it. No liability, please. Scaling it up and rolling it out, as indicated, we tried to create a prototype to convey the message, to indicate what should be possible. It is not possible yet. And although this thing is a live thing, and you'll see that if you go to that URL, I'm not sure whether it's the best thing to scale up and to use in all genebanks. It could be, but then possibly we should have a very experienced R programmer look at the code, because it was one of my colleagues, a talented one, bioinformatician, who made this, but it's not his job to make this type of prototypes. I could imagine that if people would be interested, and let me know if you're interested, or let the Crop Trust know, or anyone know, possibly we could find a way to use the diversity trees that have been created in the CG genebank platform to create interfaces like this, because you have the data already. They are in your database. The trick of pulling them out might be a difficult one, but requires a one-time effort in writing the script to create the right data. So I hope this answers your question.
All right, we have a couple more and I think we'll be done, but just in case you want to see Theo today, how he looks today, there's a little button at the middle, at the top of the screen, and you can select that and say view who's talking. So if you press that button in the middle at the top, you can actually see our speaker today answering the questions.
I don't recommend it, by the way.
Okay, so a few comments by Shella Kell. Says, imagine if all gene banks that provide data to Eurisco would use this tool and the information were freely accessible. I think it would be a game changer. So that's just a comment.
I love Sheila, she knows that.
Yes, okay. And there was another one, we've answered that one. Share the code, we've answered. Going back then, a couple of questions about the seed monitoring and the seed lots. What protocols do you opt for in crop well relatives and their regeneration?
Could you repeat the question, please?
What
sorry.
protocols, and this would be viability testing protocols, I'm imagining, do you opt for crop wild relatives and their regeneration?
Yeah, so first of all, crop wild relatives can best be conserved in their natural habitat. It's having crop wild relatives in your gene bank is a pain, and you all know that if you have crop wild relatives, they shatter or the seeds fly away and they don't germinate at the same time, and you have to harvest 10 times, and I mean, it's a nightmare. But if we want to do, if we want to make that stuff available to users, readily available to users, if we want to prevent them from getting lost because of climate change or other threats to the natural populations, we will have to put them in genebanks. How then to determine the germination? Well, you tell me. There are some resources, and I think that Q has a very nice website that gives some inspiration on how to do germination tests on wild species per species. Possibly we should exchange more experiences in this regards, because many gene banks invent the wheel themselves again and again, is my impression. I don't have the answer. And if I understand correctly, it is very difficult, and very many gene banks use different thresholds. We use 60% for wild relatives. Why? Because we don't know how to get them germinating, right? Also, in terms of regeneration protocol, that will be species specific. Is it the cross-pollinator? Is it the self-pollinator? Does it require vernalization? It's difficult. Running a gene bank is difficult. That would be my advice. Make sure you get very good curators. We have very good curators. They know how to do their job, and even they sometimes struggle with the crop wild relatives.
Okay, and lastly, there's a question from Marcus Opperman. His question is about the bulking versus the requests from users, and it is as follows. Bulking accessions can simplify conservation. On the other hand, we see the demand for homozygous accessions that can be used one-on-one in genetic research and can be reproducibly delivered. Thus, we have a contradiction between the baseline of plant genetic research conservation and the requirements for the usability of gene bank material. What would be your strategy here?
So, the strategy at CGN is peculiar. We at some stage were in the position to have our lattice collection sequenced, and at that moment it was clear that it would only be done with one plant per accession. It's a self-pollinating crops, but we know that there's diversity within accessions quite considerably, even in modern varieties, small, but still. So we had the option to take one line, have it sequenced, and forget about the line. Then the sequence would relate to probably one line in the accession, or to conserve that line, which would generate lots of costs. The taxpayer is not paying us to double our collection because somebody wants to do a sequencing. So we decided to have what we call special collections, which are separate sets of material, in this case single C descent lines, which do have the advantage that they've been sequenced, often used in phenotyping programs. You know what you're talking about, that line. You can make the relationship between the phenotype and the genotype, do all those beautiful research things that need to be done. For my grandchildren, they're interested in the regular collection. There we use the taxpayers' money. For the special collections, the users have to pay if they want to use it. So they have to be, there we have to recover the costs. That's on how we do it at CGN. The general question on whether to split or bulk is a complicated one. And I think that Marcus listed a few of the issues. Earlier, we had Graner pointing out to the authenticity of the thing and the relationship, the cultural heritage component. This is complicated, and that's why we wrote a technical bulletin, number 5 of IPGRI. It's online available. There we try to list all the arguments based on the knowledge we have had way back then to base your decision upon. And it's always a balancing of pros and cons for the one or the other. So I can't say what's wisdom in your case. I make of every answer a speech. Isn't that nice, Yanni?
Perfect. Thank you so much, Theo. Thank you to you for your thoroughness and your willingness to be our first person in the GROW webinar. Thank you to all the participants for coming in today, and your patience also for waiting for us to redirect you because they hijacked our site. And thank you for organizers, Faye and Linus. Been wonderful to have worked with you. Look forward to the February GROW webinar. We'll have another very provocative topic, and until then, stay safe. We'll see you sometime soon. Thank you very much, everybody. Bye-bye.
Bye-bye.